All right, well, it's nice to see all of you relatively dry and back here. If you didn't get the announcement on Canvas, I did delay all of the first half of the course's assignment deadlines 1 week. So chapter 1 isn't even due until September 7th, so next Tuesday, because Monday is Labor Day. Coming up in chapter 3 that I plan to go over today isn't due for a couple of weeks. So I was looking yesterday at the text and the assignments just to see who's digging into what, and nobody started chapter 3 yet, which totally makes sense. I'm not ragging on you for that. It's not due for a couple of weeks. But it does change what I wanted to do in the classroom today a little bit. I was hoping to answer some of your questions to start out with, which I'll still do if anyone has any questions. I just don't anticipate too many. But what we'll do today is I'll open it up for whatever questions you have as far as getting to the course or course structure. If you've jumped into the homework, we can talk about those. And then I want to do something that I don't typically do anymore, which is lecture a little bit on time value money. I want to introduce the concept that is introduced in chapter 3 together in the classroom. And along with that, we'll work through some example problems that are in the text. And we'll also work through some test bank / end of chapter homework problems, applying those concepts inside of there just to get a feel for what's going on. Now, typically what I want to do going forward is mostly, since we only get 1 day a week together, I put everything in the text and everything online, and you can kind of go through the class as if we were in there together. You've got the example videos of me working through all the problems just like I would in class and talking about the concepts, and you have all that in the text. So what I hope to do with our class time is have y'all come in, and then I'll answer whatever questions you have as you've been sort of wrestling with the material. And then I'll also give out new problems, newish problems. They'll be the same problems you've seen before with fresh numbers, and we'll kind of work them together in the classroom. So we'll have kind of like a lab session together and do essentially what you'll have to do on the exam. That is, try and solve a problem with just your formula sheet and your calculator, see how it goes, and then we can kind of deal with whatever issues come up together while I'm here with you instead of figuring that out on test. So today will be a little bit different. And all that out of the way, I'll start it up with, I'm not going to do that yet. You'll have any questions about the class structure, getting access to the assignments, anything like that. I think most everybody had access to the text. We're only missing about 10 folks so far. And that's really about right for folks who are going to end up dropping anyway, so they may not end up being in the class. Yes? Oh, just stretching. Sorry. Any homework questions that have come up? Anyone started digging? Yes, ma'am.
Not particular about the material, but will everything always be due at 10 for your class? Like
yes.
Homework, anything? Okay.
Yeah, things are going to be due at 10 p.m. for us. Yeah, I know that's weird. Classes usually get to 11:59, which I always did too. What I've found though is about half the class will be submitting stuff at like 11:50, 11:56, 11:58 as it goes in, and I don't know. I guess it's the dad coming out in me now that I have a house full of teenagers, like trying to get you to bed a little bit earlier, or at least give you a couple hours to work on the other classes if they're giving you until midnight. So that's why the 10 p.m. deadline. Anything else along those lines? Yes, ma'am.
You said we can get practice questions until we try the homework?
That's right. So the practice questions are really just copies of your homework. It's the same that you'll open it up and it'll look exactly like your homework. But those have a prerequisite of the homework assignment. So they won't open up for you until you get at least a 70% on the homework. And the idea is to provide a little motivation to get in there and actually figure out the problems. Because what you could do with the practice problems is just go in and get all the solutions and then go and get 100 on your homework without learning a thing. You can still do that in the homework, but you're using up an attempt to do it. So there's just a little bit of stake involved there. That's the idea. Yeah. And this is along those lines, guys. This is the first edition of a text, and I'm putting it together a little bit differently than any of the available publishers in a way that makes sense to me and the way that I teach the class. So if you guys notice anything in the text, there's going to be typos, there's going to be mistakes. If anything is confusing or not working the way you think it should, reach out to me and let me know. So we can get it fixed. I'm in direct contact with the publisher, the person that's actually editing the text, so we can get it fixed pretty quickly usually. So let me know that stuff. If there's something that's set up and doesn't make sense to you, like I don't know why you have the assignment structured this way, let me know that too. That's perfectly fine. This class, I took this class over in 2011 when I showed up at USM, and I had been teaching it at University of Alabama before that when I was a grad student. And it's been a 10-year experiment to figure out how to set this class up to set you up for success in the best way possible. Try and get the best possible outcomes for y'all learning the material and being able to get the highest grades possible while learning the material. So if you have any suggestions whatsoever, I'm open to it. Now just send them to me. If you want to do it anonymously, we'll figure out a way to do that too. If you're afraid of like hurting my feelings or something, which isn't going to happen, I can promise, but I understand the concern when I'm the one who determines the grade. So I'll throw that out there, and I'll throw that out there several more times throughout the semester. I'd love to get y'all's feedback, both on the text and the course structure. All right, anything else? Sir.
So I've read through chapter 3, but I haven't started the homework yet. But
Yep.
there's not as much content like conceptually in chapter 3. It's more practice problems. Is the homework going to reflect that? Like majority of it be practice problems instead of like conceptual questions?
The homework will typically be about half and half conceptual and half problems. That's a really good observation. I'm glad you brought that up. I don't know how well that comes over online or on the recording. You said reading through the chapter, it's mostly problems and not a lot of concepts. I love that you said that, because what I've done is snuck the concepts into the problems. So you're picking that stuff up and hopefully not totally conscious of it while you're doing it. Because my experience with finance is what happens is you have to wrestle with the problems over and over again. And hopefully chapter 3 is relatively straightforward. I hope it comes across relatively simple, as long as you're still kind of comfortable with algebra. And if not, we'll get there. But the concepts are actually coming together while you work these problems over and over again. And that, in my experience, has been the most efficient way to lay the conceptual groundwork for that stuff. The conceptual questions you'll see at the end of the chapter, though, be kind of like some vocabulary stuff, some basic ideas of when you're calculating present value, what tends to happen to the value. We'll see that it declines. You're going to discount and get a smaller value going from future value to present value, and then the reverse. When you're going from present value to future value, it tends to grow. Like relatively simple stuff you will have probably picked up working the problems. Yeah. Sorry.
Chapter 3, you have like highlighted text saying that you're going to implement like a video of how to work it. Are you going to do that anytime soon?
Probably not going to be here for our class, because the publisher is still wrestling with getting the videos for the example problems embedded in the text.
Okay.
So I'm kind of holding back on that, because they still have to build the exams and a few other things that are far more important to us. So the things that would have been in the video chapters we'll do in class here. Yeah, good question. You'll see stuff like that occasionally through the text, like there'll be a highlighted section of like insert introduction to time value of money here, and it's not there, right? It's just a highlighted section, and that's a note to me to remember to go back and do that. Or send it to the publisher, it's really already done. Yes?
If I'm trying to pull up the text, I keep getting an error message.
Okay,
I was trying to pull it up for class so I could
Yeah.
see it.
let me see, you got it right here, let me see.
I think that's still-
And has that been happening the whole time? Or did it just start?
It just started.
Okay, I would try closing everything out and try logging back in. You've had access to the text before? It may be an issue with cookies and security settings.
Oh.
All that. If that doesn't work, I'll pull up a website. I don't speak Apple too fluently. We'll figure out how to change the security settings to make that work. All right, anything else before we really start having fun?
Could
Yes,
you tell us about the calculator again? Or we need to buy?
yeah, just which one?
Yeah.
Kind of thing? Yeah, if you're gonna go out and buy one, I recommend you get this guy. Actually, it doesn't look like that anymore. Let me pull it up. That's an older version. If you're going to get one, I recommend the Texas Instruments BA2 Plus. And there are two different versions. There's what they call the advanced, and there's what they call the professional. Professional is a little more expensive, and I've never really, other than just to play with it, I've never used the advanced function on those. So if you're going to buy one, I'd say spend a little less money, unless you're planning on sitting for the CFA later. Some of that stuff might come in handy. But that's the one. That you're looking for there. And I think it may be in the welcome announcement on Canvas. There's actually a link to Amazon if you're shopping on it. It looks like you got it though. I think you're good. All right, all good stuff. It's all telling me you guys are already thinking about the class and wrestling with it, which makes me feel good. Anything else? All right, you look super excited and ready to get to work, so let's do it. That was sarcasm, by the way. All right, before we go there, let me lay a little bit of a foundation. Those of you who looked at the chapter, this is going to sound awfully familiar because I'm stealing my own stuff. Chapter 3 begins our discussion of what we call time value of money in finance, and that's really what finance is. Finance is about managing money, and the thing that finance does that is different than most other disciplines that are involved in managing money, like accounting, is we recognize the time value of money. That is, there is a time component to the value of money. We're used to thinking of value in terms of just dollars, right? $100 is $100. Well, it turns out that's not a complete description of the units that are attached to money, right? If I talk about $100 today, if I'm going to sell you something, I'm going to sell you something that's worth $100 today, right? Or you can give me $100 today and I'll return your $100 2 years in the future, right? I'll just give you back your $100 2 years later. Are those two $100 things equivalent to you? Right? Is $100 today worth the same to you as $100 2 years from now? Right? Probably not. And it turns out we're going to come up with a mechanical way to account for the time value of money, but I can show you that you've been doing this your entire life, at least as long as you've been aware that things have value. You've been applying this time value money idea. Let's say that I'm starting a business and I'm looking for investors, right? I'm going to invite you all to potentially be investors if you would like. I'm going to start Stelk Inc. And the investors I'm looking for are going to come in $100 tranches. So each of you have the opportunity to invest $100 in my business, and I promise to repay your money in 1 year. So 1 year from today, 1 year from the time you give it to me, I'm going to give it back to you. Right? And what I'm going to do is I'm going to auction off these investment tranches. Right? And I'm going to take the first 5 investors that jump in. Right? So I'm only looking for $500, $100 per investor. And the first 5 people that jump in, I will take on as investors. After that, it's closed out, right? And I've got everything I need. So here's where the bidding starts. If you give me $100 today, I will give you back your $100 in 1 year, once the business is up and running and earning income. Do I have any takers willing to invest in Stelk Inc. to give $100 today and get $100 back in 1 year? Tough crowd. Coming in? Okay, we got one. All right, so we're down to 400. All right, so we've auctioned off one tranche. Second tranche, if you give me $100 today, I will pay you back $120 in 1 year. Do I have any takers for the second tranche? No. All right, we got 2. We got 3 left. All right, third tranche. Y'all are holding out. If you invest $100 today, I'll pay back $150 in 1 year. Do I have any takers? Tranche number 3. Once you go up, we got more than 3 coming in, so we're closed out. All right, so I've got my 500. I'm paying back 100, 120, and 150 to a handful of investors. Now, why? For those of you that held off, you know what? Why? If you weren't willing to invest $100 and get $100 back in 1 year, why not? Why weren't you willing to do that? You're getting your money back.
It's not a profit, though.
It's not a profit. Why do you need a profit?
So how are you making money without a profit?
Are you making a profit in any of your other money?
Wait, what?
Are you making a profit in any of the other money you have?
Not necessarily. You might be.
Okay. So when you want a profit, why do you want that profit? What's underneath that? You're not wrong. I want a profit on my money too. I'm not giving it away. Right? But what's packed underneath that? Why do you want, we call it a return, a profit, right? If you're going to invest money in something, you want to get more back than what you invested usually, unless you feel like it's a really safe investment, you need to park cash, right? Why is that? What are you trying to get compensation for? Say that again? Time. Okay, so your money's tied up, right? You're going to give it up today. What else could you have done with that money today if you weren't going to invest it in my business? What'd you say? Oh, buy groceries. I thought you said bet on horses. Good. That's right. Good. Buy groceries. That's a good one, though, especially with inflation right now, right? We've got 2 teenagers and 1 preteen in our house. And I can tell you the price of meat and milk and peanut butter has gone up quite a bit in the last couple of years while their appetites have grown. So spending money on groceries matters. Okay, so there's opportunity cost packed in there, right? You could do something with that money today. You could buy groceries with it. You could buy I guess nobody buys CDs anymore, but you could, I don't know, buy video games or clothes or whatever, right? For me, it would be beer and pizza, right? Or probably good whiskey now. I get fat on beer too easily these days. So there's opportunity cost baked in there. Somebody said time. Baked in with that opportunity cost, you mentioned groceries, so there's a couple of things getting tied in there. There's inflation over time, right? Prices in a healthy economy tend to rise over time. So if you're going to give up your money today, when you get it back later, if you're not getting more back than what you invested, you've actually lost purchasing power on your money. Like if you give up $100 today and you get $100 in 1 year, now inflation's been like annualized 5% averaging over the last couple of months, right? So you will have just lost at least 5% of your purchasing power. And that's really minus the volatile food and energy sectors, which is what we all spend most of our money on. So there's inflation packed in there. There's opportunity cost. You could do something else with it. There's also risk. How do y'all know I'm good for it? How do you know my business is going to work and you're actually going to get your money back? Right? So there's some risk involved there as well that you also want compensation for. So all that stuff is packed in. And to account for that, we say that money has time value. Right? So cash flows that happen at different points in time, it's not a complete description of the units just to say dollars. $100 today is not the same thing as $100 in 1 year. We need a way to kind of value money over time and say, okay, if I'm going to give up $100 today and I'm going to get $150 in 1 year, are those two things equivalent? Am I being compensated for my opportunity cost, for inflation, for the risk I'm taking on? I don't know. We need a way to account for that, and that's what finance does, and that's what we're going to start looking at today. Okay, let's start with an admittedly very stylized example that's somewhat simplified. We're going to look at two things that'll help kind of drive this point home on how we work the conversion factor for time value money. Because what we're going to find out is it's a simple conversion factor that we apply that will convert dollars today to dollars in the future and dollars in the future to dollars today. It's going to be a simple math problem that we do, and we'll see how it works with something that is a little more obvious to all of us. All right, so let's say, this is straight from the text. Let's suppose you've been mining Bitcoin for the last 6 semesters, which all of us have been doing as a hobby, right? I don't. You have an offer to trade 1 unit of your Bitcoin for 41 units of Ether, which is Ethereum's unit of value. Should you accept the offer? So should you trade 1 Bitcoin for 41 Ether? What do y'all think?
Depends on the value of Ether at that time.
Okay, it depends on the value of Ether and Bitcoin, right? So we don't have enough information to answer this yet because these two things are not the same thing. We can't compare them directly, right? The basic way that we make decisions, and we're all familiar with this, is we try and come up with the value of any decision. In this case, it's a trade, where we look at the value being equal to the benefits. It's supposed to be a minus. Minus the costs, right? Benefits are what you get. That's what you're going to receive from the trade. Costs are what you have to give up in order to get that benefit. So for this particular trade, the value of this trade go away. So the value of the trade, if I were to just plug directly into this, the benefits, what I'm getting, I'm going to give up 1 Bitcoin if I take this trade, and I'm going to receive 41 units of Ether. So I would get 41 units of Ether. That's my benefit. What I have to give up and subtract my cost is 1 unit of Bitcoin. And the value of that is equal to, man, we don't know, because we don't know what the value of each of those are. They're expressed in different units, so they're not directly comparable. So we're not done yet. We need some more information before we can figure this out. Okay? And there are several different ways we could do this. We could convert the units of Ether into units of Bitcoin. We can convert the units of Bitcoin into units of Ether and just get everything in the same units. What we will typically do, though, when we have two things that are not expressed in dollars, we will convert everything to dollars at their current market value and then make the value judgment based on their dollar value, okay? So let's collect some market information for these guys. Let's say that that's not the one I need. Let's say that Ether one unit of Ether is trading for $226. Ooh, I haven't practiced writing on this thing since last fall. So my handwriting will get neater as the semester goes on. I'll get used to it again. All right, so 1 unit of Ether is worth 226 bucks. One unit of Bitcoin. These guys are so volatile. These were actually accurate prices over the summer when I pulled them. I'm sure they're not now. 1 unit of Bitcoin is trading for $9,080. Okay, now I'm going to rewrite the units on these a little bit differently, and then we're going to see how they work as a conversion factor to get units of Ether into dollars and units of Bitcoin into dollars. So let's rewrite this. Let's say 1 Ether, 1 unit of Ether. The number attached to the conversion factor is 226, right? It's $226 per unit of Ether. All right, so if I write those units attached to it as a ratio, it's dollars per unit of Ether, right? We could put a 1 in front of that Ether. It's $1 per 1 unit of Ether, $226 per 1 unit of Ether. Similarly, I can write the Bitcoin units as 1 unit of Bitcoin. Push this over a little further. And 1 Bitcoin, the number attached to this conversion factor is 9,080. The units are dollars per Bitcoin. Okay, now we're going to use these conversion factors with the units expressed as ratios to convert each one of these, the units of Ether into dollars and the units of Bitcoin into dollars. Check this out. All right, so let's start with Ether. We're going to convert Ether to dollars. We have 41 units of Ether. And we're going to multiply that by our market price of Ether, which is 226, and that is dollars per unit of Ether. All right, now this 41 Ether over here, I can express the units attached, so just 41 Ether. I can write that as a ratio as well. I can just write it over 1, Ether over 1. Anything over 1 is itself, right? And now look at this multiplication we're doing. We have 2 ratios here. I have Ether over 1 attached to the 41, and then I have dollars over Ether attached to the 226. I've got Ether in the numerator over here, and I'm multiplying it by something that has Ether in the denominator over here. What happens to those 2 expressions of Ether when I multiply them together? Cancel out. Ether over Ether is 1, right? So they cancel out. Those guys go away. Right? They cancel out. And so then I'm just left with dollars over 1, which is just dollars. So then I need to multiply the numbers. 41 times 226 turns out to be 9,226. And the units I'm left with are just dollars, so I can just stick a dollar sign out front. And so I've taken my 41 units of Ether, multiplied it by the market price, and what I've really done by doing that is cancel out the units of Ether and just turn it into dollars. Now just simply dollars. So that 41 units of Ether is worth $900. That's $909,226. All right, we can do the same with Bitcoin. We'll write it out just for the sake of argument, but it is just one Bitcoin, so it can end up being its market price. So one Bitcoin times 9,080, and that is dollars per Bitcoin. All right, with the one Bitcoin, I can stick that guy over one just to see that it's a ratio. I've got the same deal. I've got Bitcoin in the numerator here, Bitcoin in the denominator here. Those guys are going to cancel out. And I'm left with 1 times 9,080, which is just 9,080. And the only units I'm left with are dollars. Okay, so now I've expressed my benefits and my cost in dollars. With this trade, I'm giving up 1 Bitcoin. Right, so that's my cost. That's what I'm giving up. I'm going to receive $9,226 worth of Ether. So that's the benefit of this trade. And now I can plug into this value equals benefits minus cost expression, because everything's expressed in the same units. I can compare them directly. So let's plug those guys in. And value, again, my benefit is what I get. That's $9,226 worth of Ether. I'm going to subtract from that what I have to give up. That's $9,080 worth of Bitcoin. All right, so if I were to execute this trade in dollar terms, I have a positive value of $186. In other words, I'm receiving something that's worth $186 more than what I am giving up. Okay? So now that we've looked at it through this lens, what do you think? Good trade, bad trade? Should we do it? In terms of just dollar value, right? Like set aside your friendship or whatever is going on outside just the value of the problem. Yeah, we're better off. We're $186 better off. Right? Now let's suppose you have no interest in Ethereum, right, at all. You can't do anything with it. You don't plan on doing anything with it. Right, so you're going to get these 41 units of Ether. Well, that's not $186 to you. It's 41 units of Ether, right? So even if you're not going to use it, does this trade still make sense? Do you think you should probably still do it?
I don't know. It needs to be 9,266 instead of 9,000.
Oh, 226. Okay. 9,266.
Yes, sir. There's a dollar of Ether that we got.
Good. I should
Everything's right except for that. Like
actually plug it in,
186
huh?
well. Yes, sir.
Let's double check. Yes, 9,266. Sorry about that. So I get for not plugging it actually in. Then that subtraction.
The subtraction is right.
Interesting.
Oh, the subtraction is right. The final value is right. But
Thank you. All right, so that value, if we weren't tracking that, the value of Ether should be 9,266, not 9,226. But the value of 186 comes out right. All right, so even if you don't know how to use the Ether and not do anything with it, you can always turn around and sell it, right? You could turn around and convert it back to Bitcoin at the market prices, and you'll have $186 more worth of Bitcoin. You could just cash out, spend the money on whatever you want to spend it on. You know, it's an extra almost $200 you could do something with. So what's embedded in this idea is the lens we're looking at this stuff through is that of a corporate financial manager, right? You're in charge of someone else's resources. So when we're making decisions like this, we're doing it based on market values. What are things worth? Your personal preferences and all that kind of stuff don't come into play. Maybe you don't like Ether. Maybe you have like moral issues with the people who are running Ethereum. doesn't matter. If this trade is put on your plate and you're in charge of someone else's resources, it increases value for the owner of those resources, you should execute it. So the value of trades is determined by market values, not what you personally can do with the assets that are involved. All right, any questions on doing those actual calculations? Coming up with those numbers. It's not too bad, right? In fact, you're probably sitting there thinking, that is really obvious. Why are you making us sit through this, Dr. Stelk? And I'm glad you asked. Here's why. It turns out the time value of money calculations work exactly the same way. All we're going to do is take units that are attached to dollars today, and we're going to convert them through a conversion process. It looks exactly like this into dollars in the future. And then vice versa. We can take the units that are attached to dollars in the future, and we can convert them back to dollars today using this exact same process, right? Check out this parallel. All right, we're going to take this problem that doesn't seem like it's related. We're going to see how it is, though. All right, suppose you are offered the following investment opportunity. You can invest $1,000 today. If you invest $1,000 today, you can receive $1,070 in 1 year. Should you accept this investment opportunity? What do you guys think? Give up $1,000 today, get $1,070 in 1 year. Sound like a trade worth making? See some heads shaking no. If no, why not? I'm not saying you're wrong. I think you're probably right.
You get higher returns and other, you can invest your money in things like ETFs wherever you get higher returns.
Okay, you might get higher returns elsewhere, right? That's a $70 return on a $1,000 investment. So that brings an interesting issue into this problem, right? With Bitcoin and Ethereum, it was really obvious we were dealing with two different units. We can't compare those directly, so we had to convert them to dollars. Well, when we're looking at dollars, it gets a little more confusing, right? Well, they are expressed in the same units. They're both dollars, except they're not. One is dollars today, one is dollars in 1 year. What's packed into that dollars in 1 year is the time value, the risk associated with it, inflation that might occur over that period, your opportunity cost. What else could you do with that money? What other investments could you make if you have $1,000 to invest? So just like with Bitcoin and Ethereum, we needed to know the market prices before we can make a decision. The same thing is happening here. We need to know what the market rate of trading dollars today for dollars in 1 year is before we can make a decision. Just occurred to me, I can make that a little easier to read. So just to make sure we have it in the notes here, we're tempted to do what obviously didn't make any sense with Bitcoin and Ethereum, where we can look at the value of this trade as benefits minus the costs, where the benefit is the thing you get. So if we make this investment, that's the 1,070 we would get in 1 year. And that is, instead of just putting dollars in front of it, I'm actually going to say dollars today. We're going to subtract from that the cost, the thing that we have to give up. We have to give up, whoops, that's dollars in 1 year, sorry. We're getting dollars in 1 year. The thing we have to give up is 1,000. And the units attached to that are dollars today. So when we go to do that subtraction, it's tempting to just say, oh, $1,070 minus $1,000. Well, that's a $70 return. And if we do 1,070 minus 1,000, we do in fact come up with a value of 70. But that's just like 41 Ether minus 1 Bitcoin. 40 what exactly? Those aren't the same units, and so the subtraction doesn't make any sense. Same deal here. We can't do this subtraction because those two numbers are not expressed in the same units. One is dollars today, one is dollars in 1 year. So this we cannot do. Before we can do this, we need to convert to the same units. So we need to convert all values to the same units first. And just like before, in order to do that, we need market prices before we can do it. The market price of converting dollars today into dollars in the future, or dollars in the future into dollars today, which is what you do when you borrow on your credit card, right? Or you make a loan. You're actually converting dollars in the future to dollars today. You get dollars today to buy whatever you want, and you're paying it back with future dollars. So we do that all the time. It seems weird to move in that direction, but we all do it. The market price of converting dollars today into dollars in the future, vice versa, are interest rates. All right, so interest rates are the market price converting dollars today to dollars in the future, and vice versa. Okay, so let's say your bank allows you to borrow and lend at 10% interest per year. Well, I know that's a weird statement. Your bank lets you borrow and lend at 10% interest per year. Of course, one, they're not going to pay you. Lending means you make deposits in the bank, they turn around and loan it out to other folks to make a return on it, right? When you actually deposit money in a bank, you are lending them your cash to do it, and they pay you a little bit of return, assuming it's in a savings account or something like that. You're not going to earn 10% per year anywhere right now, thank goodness, on just a regular savings account. So that's lending to the bank. Borrowing would be just like what we think of as borrowing, right? You borrow money from the bank, you promise to pay it back with interest in the future. So we're going to set that at just 10% for both activities. I know that's not realistic. I know the bank will charge you more to borrow than they will to pay you in interest. Right? This is going to simplify the math for us a little bit. But the concept works both ways. If those two rates are different, then we just do two different calculations, two different directions. It's fine. It's not a problem. So we're going to simplify our lives a little bit, say it's 10% in both directions, and also we're using 10% to make the math a lot easier and hopefully pull some confusion out of the system while we're looking at this. Okay, if you can borrow and lend at 10%, let's map these cash flows out on a timeline. All right, so if we're going to map out this investment, this potential investment that you can make, at time period 0, you're going to give up $1,000. All right, so that's your cost. If you give up that $1,000 today, this investment is promising to pay you $1,070 in 1 year. That is your benefit. All right, and we're going to simplify the world down to this bank that you can earn 10% interest at is your only other opportunity, right? So you can either make this investment, you've got $1,000, you can either make the investment or you can put it in the bank. Those are your two options. So let's look at what would happen if we, instead of putting this $1,000 in the investment, we put $1,000 in the bank. All right, and we let it sit there for a year. We accrued 10% interest. How much would we have in 1 year?
1,100.
We'd have 1,100, okay? We'd have 1,100. How did you figure that out? It's not a trick question.
You can multiply and add it.
Just multiply and add it. So you took 10% times 1,000 and then added that back to it, okay? So we came up with that 1,100 by saying 1,000 times 10%, which 10% expressed as a decimal is 0.1. That's $100, right? So they're going to pay you $100 in interest over that period. So you end up with your $1,000 plus 100 in interest gives you the 1,100. All right, so that 1,100, that 1,100, that's your cost for the investment. If you choose to make the investment, so you give the $1,000 to the investment, you're going to get 1,070 back. That's your benefit. That's what you're going to get. What you just gave up in order to do that was $1,000 today, yes, but if you had deposited that $1,000 in your bank account, it would have been 1,100 in 1 year. At the same time, you're going to receive that 1,070. So that 1,100 is actually the cost of this investment expressed in dollars in 1 year. All right, so for now, just believe me on that. We're going to walk through the mechanics of what's going on there. Let's just take this and plug it into our value expression, where the value of this trade is the benefits minus the costs. Now that we've expressed everything in the same units, the benefit is $1,070 in 1 year. The cost, giving up that $1,000, is $1,100 in 1 year. That's what we could have had. So our value is 1,070, that's dollars in 1 year. Oops. Minus 1,100, that's also dollars in 1 year. And that is equal to 1,070 minus 1,100 is minus $30 in 1 year. So if we were to accept this trade, we'd be giving up $30 in 1 year that we could have had otherwise, right? So with this extra information, it looks like a bad trade. We wouldn't want to do it. Instead, we just, if we have $1,000 we're looking to invest, we drop it in the bank account and get that extra cash. Okay. So how do we do this mechanically without having to draw it out on the timeline and figure out interest and add it together? Because this is just a 1 year example, right? Imagine what this would look like if we have a 10, 20, 30-year investment. Like a mortgage, how does your bank decide whether or not to give you a 30-year mortgage with monthly payments? I expect it to be a really complex problem if we're doing it this way. So we need a more mechanical way, a shorter way to be able to deal with this. And the way we do it is with what we call the interest rate factor. Okay, the interest rate factor is this expression that's just 1 plus, that's supposed to be an R. 1 plus R, where R is the interest rate per period. And for now, we can think of it as just the interest rate. I say interest rate per period to be a little more precise because when we start dealing with cash flows that happen more frequently than once per year, we're going to have to adjust that interest rate to match the frequency of the cash flows. For Chapter 3 and Chapter 4, everything's going to be annual cash flows. We're looking at annual interest rates, so you don't have to worry about it right now. Just like kind of take that statement, set it aside. We'll deal with it in Chapter 5. So you can think of R as just the interest rate for right now. That interest rate factor, 1 plus R, carries units associated with it. Okay, the units attached to that thing are dollars next period over dollars today. All right, so just like our market price for Ethereum was dollars over units of Ethereum, this interest rate factor carries units of dollars next period over dollars today. All right, so now let's look at, let's convert our cost of the investment into dollars in 1 year. All right, so the cost for our investment, if you remember, was $1,000. That's what we give up. That's $1,000 today. We're going to multiply that times our interest rate factor, which is 1 plus R. Our interest rate in this example is 10%. All right, so in this example, R is 10%, which expressed as a decimal is 0.1. All right, so when we multiply times our interest rate factor, that's going to be 1 plus 0.1. And that's going to carry the units of dollars next period. In this case, that's in 1 year. So we're just trying to push it forward 1 year. So I'm going to change the generic variable next period to dollars in 1 year. Over dollars today. And just for the sake of clarity, if y'all are like me and like math is a bit of a struggle, math's always been a bit of a struggle for me. Like now I just do it every day, so it's kind of fresh in there. I haven't done it in a little while. Just for the sake of order of operations, I'm going to simplify this a little bit. Inside parentheses, I've got 1 plus 0.1. I'm going to go ahead and add those together to simplify our lives a little bit. That's going to be 1.1, and I'm just going to rewrite this thing. You don't necessarily have to do this if you're comfortable doing that in your head. So $1,000 today times 1.1. And that 1.1, that's our interest rate factor, carries the units of, in this case, dollars in 1 year, because that's our next period, over dollars today. All right, just like we did with Ethereum and Bitcoin, I can write the units of dollars today and that 1,000 as a ratio over 1 and check out what happens. I've got dollars today in the numerator on the left, dollars today in the denominator on the right. Those guys cancel out when I do this multiplication. And I'm left with 1,000 times 1.1, and the units attached to that are dollars in 1 year. So 1,000 times 1.1 turns out to be 1,100, just like we calculated before. And I'm sure about that one. I'm going to have to plug it into a calculator. and the units attached to it are dollars in 1 year. All right, so this interest rate factor is the conversion mechanism that we use to take dollars today and convert them into dollars in 1 year. Right? It gives us this mechanical ability to do it rather than having to think through it on the timeline each time. All right, so we've already taken that and plugged the value equation. We see that it's a minus 30 in 1 year. Well, let me pause there because that's already kind of a lot. And I know if y'all are like me, if your butt's in the chair this long, start to fade a little bit. Any questions on this calculation on what's going on? Because next I'm going to turn it upside down and look at it from the other direction. It's not too bad, right? Finance isn't too scary. All right, let's flip this thing upside down. We took, in order to make this value decision, decide whether or not we wanted to make this trade, we left the benefit in dollars in 1 year, and we took the cost and converted its units from dollars today into dollars in 1 year. We can also go the other direction, and this is the direction we'll go most of the time in finance, so that's not as intuitively appealing at first. We already know the cost is $1,000. That's in dollars today, right? And that's easy to wrap our heads around because it's dollars today when we're about inflation risk, anything like that. It just is what it is today. What we're going to do now is take that benefit of 1,070 and convert it into dollars today and compare it to the cost and see what happens. Right? And the way we're going to do that is by taking this interest rate factor, right? This 1 plus R guy here has the units of dollars next period and dollars today. Well, if we invert that guy, we do 1 over 1 plus R, we also invert the units on it. They're going to flip upside down. We're going to have dollars today over dollars next period. And then if we take that and multiply it by our future cash flow, it's going to convert it the other way. It's going to convert it into dollars today. And when we do that, we call it our discount rate factor. And it's that same interest rate factor, just 1 plus R. We are inverting it. We're saying 1 over 1 plus R. So we just flipped it upside down. And what happens is the units flip upside down when we do that. And the units are now dollars today over dollars next period. All right, so now let's convert our benefits to dollars today. And our benefit from the investment, that is what we get if we were to take the investment, is 1,070. That's dollars in 1 year. I'm going to multiply that by our discount rate factor, which is 1 over 1 plus R. Right? Our interest rate is 10% in this example. It hasn't changed. So R is 0.1. I'm going to go ahead and write 1 plus 0.1 is 1.1, just like we did before. So 1 over 1.1. And then the units attached to this conversion factor are now dollars today over dollars, in this case, in 1 year. So So now when we take this $1,070 in 1 year and multiply it by this discount rate factor, 1 over 1 plus 1, that has units of dollars today over dollars in 1 year, I can write the dollars in 1 year attached to our benefits as a ratio. And now I've got dollars in 1 year in the numerator, dollars in 1 year in the denominator. Those guys are again going to cancel out when we multiply them. And I've got 1,070 times 1 over 1.1. Which that I can't do in my head, so I'm going to cheat and look at my notes where I've already done it. 927.73. You know, in fact, just for the sake of, again, algebra, maybe not being the freshest for everyone, let's rewrite that. We can rewrite 1,070 times 1 over 1.1 is the same thing as 1,070 over 1.1. Right, so you just do 1,070 divided by 1.1. It's equal to $927.73. And that is the only units we have left are dollars today. All right, so that's a bunch of math and a bunch of numbers. I'm going to put this in a picture, which my dad always makes fun of me. It's like, seems like whenever somebody gets a PhD, they can't explain anything without drawing pictures. And I think that's probably true. So look at these cash flows on a timeline and get a feel for what we actually did. All right, so in this case, we had our cost that we would have given up of $1,000 right here. The benefit was 1,070. And what we did this time is took that benefit, applied the discount rate factor to it, which we call discounting. So we took 1,070, divided it by 1.1. And what we did was convert the units from dollars today, or dollars in 1 year rather, to dollars today. And found that the benefit, if we were to express it in dollars today, based on the interest we could earn by putting it in the bank instead, is that benefit of 1,070, instead of expressing it in dollars in 1 year, we express it in dollars today, it's 927.73. Well, now we can plug into that same value equation, or value expression, where the benefits, what we're getting, are 900. I'm just going to put dollars on it this time, since dollars today is we can think of as just dollars. So 927.73 is the benefit. That's what we get if we were to take the, expressed in today's dollars, if we were to take the investment. What we have to give up is $1,000. And so the value of this trade, if we're going to accept it, is a negative $27.27. All right, so still a negative value. We're giving up value if we trade it. All right, now does that number make sense to anybody? Can you like intuitively understand that 27 number? That's tough, right? Like what the heck are we talking about? That 1,070 in 1 year is the equivalent of $927.73 today. Right, that's kind of weird. That's a weird way of looking at the world, as my wife likes to frequently remind me. We have done nothing different here than we did the other way. When we took the costs and converted them into dollars in 1 year, that made a little more sense, right? Because we're used to thinking of interest compounding over time. This is exactly the same mechanics involved. We're just running backwards instead of forwards, right? And we came to, this is important, we came to the exact same conclusion. When we converted the cost to dollars in 1 year, we found that, oh, we're giving up $30 in 1 year if we do that. That's not a good trade. I shouldn't do it. Well, here, we're saying we're giving up the equivalent of $27.27 today if we do it, and we shouldn't do it. It's not a good trade. We came to the same conclusion. This number is just a little weirder to wrap our heads around. Those two numbers, it turns out, this $27.27 today and $30 in 1 year are exactly the same number. Exactly the same. They're just expressed in different units. Watch this. If I take that $27.27 today, multiply it times my interest rate factor of dollars today, of dollars in 1 year over dollars today, those dollars today cancel out, and I'm left with dollars in 1 year. Anyone have a guess what that number is going to come out to be? 30, yeah. Maybe some small rounding errors if you round to the nearest penny instead of doing it in a spreadsheet or maintaining more decimal places, but it's exactly 30. Okay. So these two ways of looking at this transaction, whether we convert it into dollars in 1 year, which is what we call future value. When we're taking cash flows today and converting them into cash flows in the future, we're calculating future value. That makes sense. We're not a creative bunch in finance. So future value is what happens later on in the timeline. That is exactly the same as taking future values and converting them to what we call present values, dollars today. If we're going to make this value judgment on these trades, it doesn't matter which one we do. If we convert everything to future value, we convert everything to present value. It's the exact same mechanics involved. We will come to the exact same conclusion. What is important is before we compare or combine any cash flows at all, we have to make sure they're expressed in the same units, which means we have to convert everything into either dollars today, dollars in 1 year, whatever. It doesn't matter. Dollars at some point on the timeline, as long as they're all happening at exactly the same time, or we've converted them to be happening at the same time, expressed them in the same units, then we can do this, we can apply this value expression and come up with a correct decision, right? Just as long as they're all in the same units. All right, a couple of quick ideas, really more vocabulary kind of stuff, just to make sure we're on the same page going forward. Say values today. Another way we can write that, we're going to work with timelines a whole bunch. So we can say at time 0 on the timeline. So values today we call present value. And we will very frequently abbreviate that as PV. Values, or I'm saying values, we can also just think of cash flows. We can use those interchangeably for the time being. So values in the future, we call, again, creatively, future value, which we will often abbreviate FV. Right. There is a general equation that we use, moving from present value to future value. We're actually using it all through here, just hadn't written it out yet. where the future value of what we call a lump sum, so just a single cash flow, the future value is equal to the present value times our interest rate factor of 1 plus R raised to the n, that's a lowercase n. And that n stands for the number of periods. This equation right here, this is our basic time value of money equation. This is what underlies everything we're going to do in this class. In fact, it is what's beneath everything in finance, right? Or finance, whichever, talking about the verb or the noun. Everything from these simple cash flow structures that we're looking at here up to the most complicated derivatives that brought the global economy to its knees in 2008. This is it. This is the relationship that's underneath everything. And this is what we're going to use over and over and over again. The equations will get a little more complex when we have multiple cash flows over time, but it's still this exact same relationship at work. Just the arithmetic gets a little more, a little fussier to deal with. This equation assumes you've got a present value and you're moving to future value. When we're converting from present value to future value, we call that compounding. Things are compounding and getting bigger. So moving from present value to future value, it's called compounding. All right, and importantly, file this away because it's going to be really good for gut checks as you're working problems and good to know conceptually as you're getting your arms around this stuff. When we're compounding, when we're moving from present value to future value, we're multiplying times 1 plus some positive interest rate, right? So the values will always be getting larger, assuming a positive interest rate. Negative interest rates are a weird world that exist in Europe sometimes, but not that often. So when we're moving from present value to future value, we call it compounding, and values are getting larger. So when you're working a homework problem, and you figured out that you've got a present value and you're calculating a future value, you know that whatever number you come up with should be larger than the one you started with, right? So you already know kind of what answer you're looking for before you even start working the problem. All right, just like we did, so that's moving from time period 0 to the end of the timeline. We can flip that on its head. We can take future values and convert them to present values. It's this exact same equation. We just rearrange it and solve for present value. So the present value is equal to whatever we have for a future value times, now instead of our interest rate factor, it's our discount rate factor. And we're moving from a future value to a present value. We call it discounting. Right, so we're applying that discount rate factor. And in this case, we're dividing by 1 plus some positive interest rate. We're dividing by something larger than 1, so the values are always getting smaller, right? Discounting, just like you're getting a discount at the register on whatever you're buying. All right, then you're going to pay less than whatever's on the price tag. All right, I know we're getting close to time, and that's a lot to take in all in one sitting, especially if I haven't looked at the chapter yet. I cannot stress the importance of this chapter. I know it probably seems fairly straightforward with what we're doing, and it kind of is by design. Like we're really kind of doing the crawl, walk, run process of learning this stuff. Please don't skip over reading this chapter, working the example problems, watching the videos. Yeah, some of it's going to be a repeat of what we did in class by design. It's not going to hurt to have multiple exposures to this stuff. It doesn't, for me at least, I've never been accused of being the brightest one in the room, but I have to marinate in this stuff for a while. I can't just look at it once, go, okay, that makes sense. I know what's going on now. It never works that way for me. I got to have one exposure to it, try the problem, go, wait a minute, I screwed that up. I didn't go back to the text and watch the example problem again, and then go back and try it again. Make sure you're having those multiple exposures to this content, especially in this chapter. It's laying the foundation for everything else we're going to do, and it's going to make your life so much easier if you really have your arms around this stuff. Chapter 4, we start to write like the rocket boosters in chapter 4. In chapter 3, we're looking at what we call lump sum cash flows. It's just a single cash flow somewhere on the timeline. In chapter 4, we're going to look at every type of cash flow that is out there in the world, and things get complex real quick. So if you've got this stuff down, and I mean down cold, chapter 4 is going to be, I wouldn't say a cakewalk, but way easier than it will be if you're still confused on this stuff. So we've got some extra time built in now, way more than I intended. Please take advantage of it. Dig into this stuff pretty deep. Really get your arms around it. Lay that foundation, and then building on it's going to be a lot easier for the rest of the semester, and your life's going to be way easier. All right, if you'll have any questions over the next week, I won't see you for at least a week. Please feel free to reach out. Discussion board, if it's homework problem related or class related. If it's more personal, feel free to reach out over email, phone call, or text. And I will see y'all next week. Yes, ma'am. Tell me when.
Right here.
Okay. And I know a bunch of y'all left already. I'm going to print this as a PDF, the class notes, and I'll post it on Canvas for folks. Yeah.